Hi, good afternoon. I am Rohit Parjanya. I am currently pursuing Masters in Computer Science and Engineering from Indian Institute of Technology, Jodhpur, India. Our group includes Dr. Suman Kundu from Cognitive and Social Analytics Lab, Department of Computer Science and Engineering. And thank you very much for giving me this opportunity. And let me start the presentation on FPPR, Fast Pessimistic Page Rank for Dynamic Directed Graphs. Before that, let's see what is PageRank and why it is important. PageRank is conventionally used for ranking web pages, and it is considered as nothing but the probability of reaching a node from every other node. When coming to why PageRank is important, it is still playing a supporting role in Google search for ranking web pages. Apart from that, it has applications in recommendation systems and finding top influential nodes in Twitter networks, etc. And as PageRank is node centrality measure, it has its own applications based on the problem statements. Before entering into our approach, let's see few more questions. Why fast and dynamic PageRank algorithms are required? The calculation of PageRank on huge graphs is cumbersome. For example, real-time use cases like finding top K popular products, etc., will need high-speed computation of PageRank. And in today's age of information technology, we see more and more dynamic networks like Twitter mention network changes with each tweet post and product purchasing network changes for every product purchased. And one major concern is that PageRank algorithms lack the flavor of dynamism. Monte Carlo based algorithms are randomized algorithms which can approximate the PageRank. There are many Monte Carlo based algorithms. And one of our interest is Monte Carlo complete path, stopping at dangling nodes. In this type of methods, our random walks are simulated from each node, and it takes note of visits at each node. And the final rank vector is defined as pi equal to visits of each node divided by the total visits. And note that random surfer moves with the probability of 1 minus rho and stops with the probability of rho. When coming to our motivations, one question that pops out is that can we calculate the PageRank on dynamic graphs? One naive approach is to recalculate the traditional PageRank algorithm after every update in the network. And second approach could be considering one of the dynamic PageRank algorithms in the literature like FIPR, fast incremental PageRank, which includes updating specific path in the network for which new update might cause disruption in the PageRank scores. And the second question could be, can we speed up the process? We believe to speed up the process, we need a simple formula that could approximate PageRank scores. And we came up with the simple approach. And our approach is as follows. At time t, we assume that PageRank scores of all the nodes have already been calculated. And at time t plus 1, let's consider a new node d that is getting added to the network along with the incoming link from C. Our algorithm calculates the PageRank score of new node considering the current snapshot of the graph as static and how random surfer in Monte Carlo based methods would have reached D. And for that, we have used a variable AV, approximate visits, which is nothing but summation of 1 by out degree of all the connected nodes to the new node multiplied with 1 minus rho, which is the probability of random surfer moving forward, multiplied with the approximate visits of all the connected nodes to the new node. If you look at the example, AV is defined as the probability of random surfer reaching D from C multiplied with 1 minus rho multiplied with the approximate visits that C currently has. And in the second step, you can see that each node is allotted with an ID, which is nothing but the chain it belongs to. The algorithm keeps track of length of each chain. And also we assume that the incoming link is linear. This assumption makes the algorithm to think in pessimistic manner that there exists a loop in the chain. If there exists a loop in the chain, then it would look like that our random walk starting from node A must have reached D in 2 hops. That is, the expected number of visits would become R into K square, where K is 1 minus rho. That is the probability of random surfer moving forward. Similarly, the next node must have gone D in 2 hops, and so on. All this contributes to the score of new node. And it has turned out that this is nothing but the sum of n terms of a geometric progression, where n is the length of the chain of incoming link. And the approximate visits from step 1 combined with step 2 would give the final approximate visits to the new node. And when coming to the experiments, we have conducted experiments on synthetically generated networks as well as real world networks, which includes random network, Berbercy-Albert network, and real world networks include Thiebaud-Richard networks. And the proposed method have been compared with 3 methods, namely power iteration, static Monte Carlo, and fast incremental PageRank on dynamic networks. For accuracy test, we have used Spearman correlation coefficient to compare the rankings of proposed FPPR with that of the comparing methods. When coming to Spearman correlation coefficient, the Spearman correlation coefficient of 2 rank vectors would be higher if the observations of both the vectors have the similar ranking. And for time complexity analysis, we have considered execution time, and note that we rerun the static Monte Carlo and power iteration methods for every update. When coming to the data set, we would like to present 3 out of 10 networks that we have experimented with, which includes Berbercy-Albert network, random network, and real-world networks. And the data set description is as follows. When coming to the results, our algorithm is performing better in terms of Spearman correlation coefficient with respect to FIPR, and also close to the power iteration method, which is considered to be benchmark. And when coming to the execution time, our algorithm is performing better with respect to all the 3 methods and in all the 3 networks. And the third rightmost column is randomly sampled 10 node PageRank scores. You can see that FPPR is having different absolute values of PageRank scores, but are identical in ranking. And we have also made note of change in Spearman correlation over time. After addition of each 10 nodes, we noted the Spearman correlation coefficient with respect to benchmark power iteration method. If you look at random network, there was dip in the Spearman correlation score of 26%, and after that it was gradually improving. And in Berbercy-Albert network, it was gradually improving and reaching close to 1. And if you look at this real world network, which we have considered Vibo-Richard networks, have highly influential nodes, have same highly influential nodes throughout the graph generation. That's why it is constant. And when coming to the pros and cons of our approach, the proposed algorithm executes in order of k into average degree time complexity, where k is the number of newly added nodes. And the proposed algorithm also takes order of v extra space, which mainly includes storing of unique chains in the network and their lengths. And the proposed algorithm could easily approximate the visits made by the random surfer, even if there exists loop in the structure. And the proposed algorithm is prone to error in the following scenarios. Like if you look at the chain ID 1, it would have correctly approximated the number of visits at D. But if you look at chain ID 2, it doesn't have a loop. This might overshoot the PageRank scores at D. And let me conclude with few points. In this paper, we proposed a new algorithm for calculating PageRank for dynamic directed graphs. We considered the node addition for the same. We showed throughout experimental results that the proposed algorithm performing better in terms of ranking from the existing FIPR algorithm, and is also much faster and providing better results. Although the algorithm is executed for node addition, we believe this algorithm can be modified and applied to link addition as well. And similarly, node and edge deletions may also be employed. These are kept as the future works in the current research. And these are the few references which we would like to present. And thank you. And now we are open to take questions.